Alright, practice problem 9.5 says indicate the orbital hybridization around the central atom in the sulfite ion. Okay, so right away we can calculate up our number of valence electrons. Okay, so we have a sulfur, we have 3 oxygen, and we have a 2 minus charge. So the sulfur we know is going to have 6 electrons. The oxygen is going to have 3 times 6, plus we have 2 more electrons from the 2 minus charge. Okay, which is going to give us a total of 26 electrons. Alright, so sulfur we know is the least electronegative, so we can put sulfur in the middle. Since we have 3 oxygens, we're going to bind 1, 2, and 3. Okay, and so we can go ahead and subtract out 6 electrons, which is going to leave us a total of 20 at this point. Now we can go ahead and satisfy the octet for each of these oxygens. So we can put 6 around each. Okay, the one thing we notice is that sulfur is going to be a few short, but if we go ahead and we draw in these 6, okay, what we notice is sulfur still doesn't have an octet. So we know that we need at least one of these to be donated in to make a double bond. Okay, and so we can go ahead and subtract another 2 electrons for that double bond, which leaves us 18. Okay, and then if we subtract out the remaining electrons, we have 16 electrons that we put around the oxygens, which is going to leave us 2 electrons left over. And so sulfur we know can hold more than an octet, and so we put those 2 on sulfur. Okay, and so if we calculate up the charge of this overall molecule, we will get that it's 2 minus. Okay, because you notice that each of the oxygens that have 6 electrons around it are each going to have a -1 charge, formal charge. That's a -2 charge overall. Alright, and so if we look at the electron domain geometry, okay, we notice that we have a total of 4 regions, okay, of electron domains, which means that we're going to have tetrahedral. Okay, in our molecular geometry, because we have 3 bonding pairs and 1 non-bonding, means that we're going to have trigonal pyramidal. Okay, and based on that, we have sp3 geometry.